There are more than 35,000 cases of Lyme disease reported nationally, but the total number the CDC suggests is closer to 476,000. To limit the number of patients left undetected, our team is going to develop a rapid Lyme disease detection. Our team is comprised of eager, motivated engineers that are excited to introduce others to our new cutting-edge Lyme disease detection technology.
I'm Kavanaugh Dowd, the CEO.
I'm Josephine, I'm the CTO.
I'm Nicole, I'm the Chief Financial Officer.
Lyme disease is passed from an infected tick to a human, and one can go months or years without detection treatment of this disease. If left untreated, it can cause chronic inflammation and affect joints, the heart, and nervous system. The more the disease progresses without treatment, the worse the symptoms get.
Our team will design and construct a biosensor to quickly detect Lyme disease infection. This will prevent the onset of harmful symptoms and allow for a more meaningful treatment. And a readily available quick diagnostic tool could greatly reduce the rates of undiagnosed Lyme disease. Detecting infection early will allow the preventable treatment that can halt the onset of chronic harmful symptoms. Currently, the CDC recommends a two-tiered testing approach, a conventional ELISA test followed by a Western blot test. The ELISA test can be extremely sensitive and provide false positives. A false positive may indicate current or past infection, and the West blot test is more specific, usually only positive if the patient is infected. However, on its own, false positives are more likely. And typically, Lyme disease will take 4 to 6 weeks to detect with these current tests.
The target market for our device is going to be the government and healthcare system, more specifically hospitals, urgent care, and clinics. Global Lyme disease diagnostic devices market size surpassed $2.53 billion in 2023 and is predicted to surpass $4.01 billion by 2032. The average customer is spending $1,200 per year right now on diagnosis and treatment of Lyme disease. For our device, we have two potential business models. The first model is the subscription method. This method will continuously send out the newest version of the sensor as updates occur. The second business model is medical device representative, which would be a salesperson tries to sell the sensor to hospitals, clinics, etc.
The antigens present in Lyme disease are outer surface protein A, outer surface protein C, and outer surface protein F, as well as FLAB and VLSE. For this bioreceptor, we'll be looking at outer surface protein A, or otherwise known as OSPA, as the antigen. And for the antibody for this, we'll be using the complementary OSPA for the antibody. One thing to note is that OSPA is highly cross-reactive with rheumatoid factor, can lead to false positives. That's why it's very important to do multi-stage testing to make sure that you're getting the correct results, which will lead to correct treatment for whatever disease the patient has.
Transducing materials are one of the main components in a biosensor. They detect a biological signal and convert it for an output in different forms of energy. The transducing material that we are using for our project is gold, and some advantages of gold is that it's relatively easy for preparation with controlled size and surface properties. It has strong light scattering and absorption and high biocompatibility. For our immobilization chemistry, biotin avidin chemistry is used, and the protein avidin binds to biotin, otherwise known as vitamin H. For this device, the gold sensor surface is treated with Nutravidin, a commercially available disulfide biotin molecule. The molecule immobilizes biotin-related antibodies that are specific to the OSPA antigen to the surface of the gold film.
The biosensor device will utilize an optical signal generation method. Optical signal generation functions by correlating changes in light intensity to a change in target concentration. Our device will utilize the physical phenomenon of surface plasmon resonance, or SPR, to generate the optical signal. Surface plasmon resonance relies on an incident light passing through a prism. Once the light has entered the prism, it travels until it strikes the interface of the prism and the selected material. The material is selected for its physical and electrochemical properties and is typically a thin gold film. This is the case for our device. The incident light is then totally reflected off the interface and exits the prism. The angle at which it exits the prism is the critical angle, and that is determined by the properties of the interface and the gold material. The interaction between the light and the interface excites surface plasmons and creates an evanescent wave. The evanescent wave is very sensitive and determines the critical angle. When the target is introduced, changes in the evanescent wave occur. These changes cause a shift in the critical angle, and this shift can be measured and used as an indicator of target presence.
We envision for our biosensor to be a 1 foot by 1 foot by 1 foot cube. This cube will be lightweight, approximately 10 pounds, and can be transportable to different areas in the lab and preferably stored on a lab counter for easy access. We would hope to make our biosensor approximately $10,000. However, there will be upgrades available, like a self-cleaning device for more money if that's what the clients would want. Additionally, the packaging that the biosensor would come in will be lightweight and eco-friendly so that whatever packaging it comes in can be easily broken down and recycled. The steps to taking samples and detecting Lyme disease are as follows. Step 1 is to collect a 20 milliliter blood sample from the patient. Then, the medical professional will place the sample into the biosensor device. Then, close the biosensor and wait 2 minutes for the test to run. After the test is completed, they'll have to take out the sample and collect the results. Then, close the biosensor again and select the self-cleaning mode to ensure the device is sterile for the next patient.
With our Lyme disease detection device, our team hopes to limit the number of people who go undetected for Lyme disease to ensure that every individual affected can get treatment they need to live a better, fuller life. Thank you for listening to this presentation.